Design Team 25063 was sponsored by the Department of Mining and Geological Engineering to compete in the 2024-2025 SME Metallic Student Design Competition, a global challenge wherein student teams from the world's top mining universities compete to design a fictional mine from pre-production to reclamation based on limited given information. I'm Carter Brown, the project lead and financial analyst. I utilized CostMine, an industry-leading software, as one of several tools to determine appropriate fleet sizing and estimate capital and operational project costs. I tabulated annual cash flows to determine the project's net present value and internal rate of return as key financial metrics of project feasibility. I worked closely with all other members of the team to keep track of progress, provide support wherever needed, and maintain a clear vision and purpose in our final products.
Hi, I'm Alexis, and I'm the Deputy Team Lead and Planning Specialist. In this role, I worked on the long-range planning for the mine where I determined the yearly tonnage produced. In Phase 2, I was able to adjust the long-range planning of the mine to better accommodate the site's needs. I also worked on the geopolitical and market strategy for the Talisman project. I evaluated the role of lithium in global markets and investigated strategies to ensure our project is capable of becoming a global leader among lithium suppliers.
Hi, my name is Greatness, and I was a tailings and infrastructure specialist. As part of the Talisman project, I conducted a comprehensive site analysis to develop an optimized layout, ensuring strategic placement of all buildings for operational safety. Leveraging the project outflow from the processing plant, I made key engineering decisions in the design of the tailings storage facility, including its management program and closure plan. Additionally, I developed a detailed project delivery timeline and established an organizational model to guide project execution.
Hi, my name is Carla, and I was one of this project's planning specialists. Alexis and I worked closely together to evaluate the provided block model and gain an understanding of deposit trends to create a life of mine or long pit shell. Using Hexagon's MineClass software, Alexis and I iterated through dozens of long pit shells to ultimately find a pit that both optimized ore access while remaining feasible. During Phase 2, we were given financial parameters that affected the classification of ore and waste, meaning we had to rework our long pit shell and all of its downstream processes. And ultimately, we more than tripled the NPV.
Hi, I'm Jake Pacheco, the Environmental, Social, and Governance Specialist. I researched Australian environmental and mining law, local Indigenous peoples and beliefs, and social license best practice to develop a legal and cultural roadmap to sustainable production. I also developed the mine's reclamation plan and outreach strategy to maintain our social license to operate a critical aspect of modern mining.
My name is Matthew, and I was the processing specialist. In this role, I was responsible for the design and optimization of the spodumene/tantalite processing plant for the project. This entailed researching processing techniques used in similar industry systems to develop a detailed process flow. By using the software MetSim, the process flow sheets were created according to current industry standards, and afterwards, the process planning was sized and costed using a combination of CostMine and integration from similar sites.
The competition has two phases. Phase 1 requires teams to generate a 40-page order of magnitude study consisting of a mine design and extraction schedule, mineral reserve estimation, tailings management plan, mineral processing plan, ESG considerations, hiring needs, equipment fleet selection and sizing, infrastructure requirements, and financial evaluation of the prospective mine. Phase 1 work was limited to a 3-week window in the fall semester in which each person was allowed to work for a maximum of 30 hours towards project completion.
6 teams qualify for Phase 2, which takes place at the SME Mine Exchange Conference, the largest mining technical conference in the world. Between a Friday afternoon and the following Sunday morning in February, the finalist teams create a presentation containing a summary of Phase 1 and a reevaluation of their proposal based on new complicating factors designed to replicate the real-world challenges that affect the plans of working long-range mine planning engineers. In both phases of the competition, outside help or advice is forbidden. Our task was to demonstrate our own competence as mining engineers.
This academic year, the mine to be designed was the Talisman project, a prospective open-pit spodumene mine in the remote Pilbara region of Western Australia. Spodumene is a hard rock lithium oxide and the predominant non-brine source of lithium for energy storage, such as electric vehicle batteries. The mine's remote location necessitated a fly-in fly-out workforce and required additional analysis of power, water, and transportation infrastructure. The FIFO nature of the mine also meant that our team, named Magic Metals for the purpose of the SME Metallic Design Competition, had to design and evaluate life support infrastructure for miners to live on site during weeks-long rotations.
Our team was notified in late December that our Phase 1 report qualified the team for Phase 2, held in Denver, Colorado at Mine Exchange. Over the next month, we workshopped with the M&E 498 Mining Engineering Senior Capstone class, researched lithium market trends, and consulted with cultural resource specialists to prepare us as much as possible for whatever Phase 2 would throw at us.
Phase 2 asked for an innovative mineral processing design and more in-depth risk assessments. But the core requirement was a global positioning strategy. Spodumene is a reliable and economically viable source of lithium right now, but there would probably be over a decade of permitting and feasibility studies before the mine we designed was ready to open, at which point a number of other currently cost-restrictive lithium extraction technologies, such as direct lithium extraction, would be ready for widespread use. Additionally, the future of EVs has become uncertain, with countries rolling back their climate commitments and reducing industry subsidies. Furthermore, China is becoming increasingly dominant in the lithium market, with lower labor costs, faster permitting, and less concern for environmental stewardship.
After a 2-day marathon of work, we presented our Phase 2 results and earned second place, outscoring schools such as the National University of San Agustin in Peru and Queen's University in Canada, and maintaining Arizona's place as a global powerhouse of mining talent at the industry's largest annual gathering.
The Talisman Project Study presents a comprehensive evaluation of a lithium mining prospect in Western Australia, underpinned by a robust technical and economic framework. The mine design incorporates an 8 pushback production schedule that allows early access to high-grade lithium, ensuring a consistent ore feed to the processing plant while optimizing operational efficiency.
The Blaine processing plant is engineered with advanced crushing, milling, and flotation circuits, achieving a 75% recovery rate for spodumene and 45% for tantalum. These processing systems are designed with flexibility in mind, incorporating real-time reagent adjustments and machine learning to adapt to varying ore characteristics and market conditions.
Tailings management is addressed through a modified centerline dam design, featuring a geomembrane liner to prevent environmental contamination. Comprehensive monitoring and a detailed reclamation plan are integral to the design, ensuring that the operation adheres to stringent environmental standards and maintains its social license to operate.
Infrastructure planning supports the technical design with proposed upgrades in power generation, leveraging expanded solar and wind capacities, and improved road access, including sealing critical routes to facilitate efficient concentrate transport. On-site accommodations are tailored for a fly-in, fly-out workforce, ensuring that logistics and personnel support are robust.
Market research and global positioning strategies are key components of this project. The analysis identifies primary markets in China, the US, and the EU, and recommends a strategic shift towards domestic refining at the Covalent Lithium Refinery in Kwinana to mitigate supply chain risks. This approach not only addresses short-term market volatility through scalable operations and flexible contract mining, but also positions the project to benefit from long-term increases in global lithium demand, bolstered by favorable government incentives and free trade agreements.
Furthermore, the study places significant emphasis on environmental, social, and governance principles. These include measures to preserve biodiversity, proactive engagement with indigenous and local communities, such as workforce hiring target of 60% local, and investments in sustainable energy solutions, all crucial for maintaining a social license to operate in today's mining industry.
Financially, the project is compelling, with a post-tax net present value of approximately $1.88 billion, an internal rate of return of 139.5%, and a payback period of 1.41 years, confirming its economic feasibility and long-term potential. And that's a wrap for Team 25063, providing mining solutions with precision, power, and a touch of magic.